How MRCP exam tests a test. Concept number 2, positive and negative predictive values. When you apply the test on a population with unknown disease status, you have to depend on prevalence. Let's know why. In a population of 200 patients where disease prevalence is 75%, 150 patients truly have the disease and 50 do not. If a test has 95% sensitivity and 95% specificity, it will correctly identify 143 true positives and miss 7 false negatives, while correctly excluding 48 true negatives and giving 2 false positives. This results in 145 positive test results in total. To know how reliable a positive result is, we divide the true positives by all positive results. 143 out of 145, which is 98.6%. This means that in this population, when the test is positive, 98.6% of the time it truly represents disease. This is the positive predictive value. Now let's discover why prevalence matters. If the disease prevalence in the same population is 25%, the positive patients will be 50 and the negative will be 150. The test will correctly identify 48 true positives and 2 false negatives, while correctly exclude 143 negatives and give 7 false positives. Total positives will be 55, and the positive predictive value will be 48 out of 55, which is 87.2%, much lower than previous example. And the opposite happens for negative predictive value. What does that mean is when prevalence increases, the positive predictive value increases, and vice versa. But the opposite happens for the negative predictive value. When prevalence increases, it decreases, and vice versa. So know the disease prevalence in your population before interpreting your test result. But this is not the end. Another test property will get you much closer to confidently reach a diagnosis, this time without even knowing the prevalence. Stay tuned for the next video.